This is the device that you're going to use to conduct experiment number 3, projectile motion. It's a projectile launcher. The projectile that we're going to use is this yellow ball, and there's a spring mechanism in this launcher that fires the ball My primary objective of this lab is to predict where the ball is going to land downrange. Now, in the end, you're going to fire the ball at, let's say, 37 degrees, but you first need to determine the velocity. How fast is this ball being shot out of the launcher? And for that, you have to fire from a horizontal position. Fire from a horizontal position using the same spring setting. Measure the horizontal displacement, that is the horizontal range, the distance from the plumb line point to where the ball strikes the floor. You do that 5 times, and that will allow you to measure that horizontal distance. You also need to measure the height above the ground where the ball is shot from. So having delta y, the height from the ground, and delta x, the distance from the plumb line position to where the ball strikes the floor, you can determine then the time. The time of flight allows you to find the velocity, how fast the ball is shot from the launcher. Once you get the velocity, you then change the angle, 37 degrees. The height changes just a little bit, so you can remeasure, because you're going to measure from the bottom of the position where the ball is shot from. Maybe a few 2 or 3 millimeters change in the vertical displacement, but that's can easily be measured. With the known velocity, you have to predict how far downrange this ball is going to travel. Now, a new time is involved because now it's being shot up at an angle. It's not being shot horizontally. And so you find that time, and then with the equations of motion, the kinematics equations, you can predict the horizontal distance. And then if you were doing an actual experiment, you will compare the predicted values based on your calculations for your velocity and of course the height with the actual values that you get when you now fire 5 times. The discrepancies between those two would include factors like air resistance, the other experimental uncertainties, fluctuations in the spring mechanism, and so on. In other words, the velocity may not be exactly the velocity that you predicted, because for one thing, when you're firing horizontal, the ball sort of plays out. It's not flushed up against the spring, but when you're firing it at an angle, it starts flush against the spring, so you don't have that give and take in the mechanism. So that sums up the objectives of the experiment. In the next clip, I'm going to work through the data. I have done the experiment for you. I fired it 5 times from a horizontal position, and from that I can determine the velocity, then change the angle 37 degrees, made my predictions as to where it's going to go downrange, and then shot it. I can compare those two values. I'm going to leave that to you to do. In the next clip, we'll just work through the numbers, and you can follow using those numbers, put them in at the particular places in the data tables, and do your calculations.